Hello students, how are you? I hope everybody is well. Today's lecture, we're going to go ahead and start looking at basic statistics for classroom assessment. We're going to start by looking at item analysis, trying to distinguish how well your assessments are written. I'm going to give you an indication of how you can tell if you're going to have to kind of look over some of your questions. If we look at the information that we learned prior to the midterm, when we looked at multiple choice items and we looked at things like Mickey Mouse distractors, ambiguous distractors, perhaps there was excessive verbiage, those types of item analysis components are going to be important in looking at this type of item analysis as well. So we're going to start off by just looking at two different types of calculations that can give you an idea of how well that item is faring for the students, or if it needs to be reviewed by you in order to be more clear for the students. I want to point out from the beginning that any of these calculations don't mean that that is a good question or a bad question. What it means is that if you get something that has a very low difficulty number or a negative discrimination number, and we're going to talk about what that means in a second, then that means that you want to go ahead and pull the test and look at the question and review it to see if that question is actually meeting your needs. Now, the great thing now with all the technology that teachers have available is that a lot of times things like multiple choice tests can be machine scored. Your schools may still have a Scantron, and the machine may have some options that you can check off in order to get some of this information done for you. At the end of this lecture, I'm also going to share a couple websites that will also give you information about your P&D values. If you are hand scoring your tests, you should not try to do P&D values for all of your questions. You really want to just look out for standout patterns. Otherwise, you're going to drive yourself crazy. So try to find like the most difficult items first and possibly the easiest problems, and then look to see if you have anything that is discriminating and you're finding negative values for. Look at the discrimination for the difficult items only. What you'll find is it doesn't really need to be done for every single item to be meaningful. One tip I always give pre-service teachers is on days that you might have an observation, for example, and you decide to give some sort of multiple choice test and that you want to share that with your post-observation interview with your principal or with your VP, doing something like item analysis is really like a wow factor, and it really bodes well for your post-observation, that you're looking at how your tests are working for your students, if they're actually measuring what they're supposed to measure, right? If they're valid, like we talked about last lecture, and also that you are reflective with your teaching. All these things kind of go hand in hand. So let's start with the difficulty calculation first. And I always feel like the word difficulty is sort of like a bad name for this calculation. I like to call it the item easiness statistic. It's one of the most reported statistics. It's very easy to use. It's basically looking for what proportion of your class of test takers got the item correct. So it will range from 0%, where nobody got that question correct, to 100%, where everybody got that question correct. And if you look at percentages in terms of decimal, then we would have the 0.0 as your decimal to say 0%, and 1.0 to have as your 100%. Items with a higher p-value are less difficult. That's why I like to call it the item easiness statistic, because a very high value will tell you that you have a very easy question. The formula for the difficulty statistic is very simple. It's just the total number correct over the total number of responses. If your student did not respond to a question, you don't count them in the denominator here. When we're looking at tests in professional development, anything standardized really, like the SAT or the PSAT or the ACTs, a lot of your tests that you guys take as teachers are also standardized. Really, they're looking for a p-value that is about 0.5, where about half of the students are getting that question correct. But it can range anywhere from 40% to 60%, 0.4 to 0.6 p-value, to kind of really start to distinguish the people that know the information very, very well from the people that are somewhat sure of the information from those who really are guessing. Criterion reference tests, which are things like the Regent, where you just have to basically hit a cut score in order to pass it, have a very high p-value. Usually those are like 0.9 or above. The discrimination statistic is another one that you see often, and the discrimination statistic is the ability of that particular test question to detect differences in the achievement. Okay, we're going to go over an example in a second. If an item is really discriminating, it means that the examinees who responded well to that item also did well on the test as a whole. The students that took the test that got that particular item incorrect also did poorly on the entire test as a whole. So there's something about that item that is able to distinguish between students that really know the material and those who don't know the material. Let's look at an example here. So let's just say that there's 20 students in a course, and the teacher gives the students a quiz that has 5 questions. If all the 20 students answer that first question correct, right, at this point, everybody has the same score. There's nothing about that particular question that is distinguishing between students that really know the material and students that do not know the material. Now, let's look at question 2. Again, all the students in the class answered the question correctly. At this point, everyone still has the same score. If the test was only 2 questions, everybody would have ended up with 100% on the test. Again, same thing happens with question 3. All the students answered the question correctly. Everybody has the same score. There's nothing about that question that is causing any variability within the scores. Now let's look at question 4. Question 4, only 6 students answered that question correctly. Those students did really well on the quiz overall. Why? Because if there's only 4 questions on the test, let's say there was just 4 instead of the 5, we're starting to distinguish 2 particular sets of students. Those 6 students have gotten everything correct so far. They have 100%, whereas the other students now have 75% because that particular question separated them from the group. Now, instead of everybody having 100%, we have 2 groups where some students have 100%, only 6 of them, and the other 14 students now have a 75%. For question 5, 10 students answered the question correctly. Now, they could have been the same 6 students that answered question 4 correctly, and for others, we don't know. But as the case may be, we're starting to see more variability. I mean, some may have 100%, some might have 80%, some might have 60%. It just depends on what they missed and what they got right. But really, these 3 questions, 1, 2, and 3, aren't making the difference in that variability. It's question 4 that made quite a bit of difference in that variability, right? And question 5 that made even more variability. You know, it just really depends on who these students were in question 5, but it started to cause changes in the overall scores in your class. And that's what we mean by discrimination. To calculate discrimination, you're basically looking for 2 different proportions and then just taking the difference between the 2. What you're going to do is you're going to find the proportion of students in the high achieving group that answered the question correctly, and you're going to subtract from that the proportion of students that did not answer the question correctly. So that's the proportion of students that answered the question correctly that did well on the exam, subtracting the proportion of students that did not do well on the exam and also answered that question incorrectly. The range will be between -1 and +1. Questions with higher discriminations are generally better, but in tests over really diverse content, they tend to be a little bit low. So if you've got a lot of things on that test that may be stretched over many different chapters or many different ideas, then you'll get a lower discrimination value. But overall, you always want them to be a positive discrimination value. You don't want a -1. As I said, the range is between -1 and +1. You would receive a negative score if more students in the lower achieving group got the answer correct than students in the high achieving group. And we're going to talk about why that might happen. It should be positive all the time. Students that did well on the test as a whole should probably answer more questions correctly than the students that did not do well as a whole. An item that has a discrimination less than 0% suggests that there's a problem with that. Now, it doesn't mean that it's a bad test item, but it does mean that you should look at it. If an item has a discrimination value that's less than 0, so you have a negative discrimination item, it's saying that there could be something wrong with that item. None of these calculations say that's a good item, that's a bad item. What it means is that you should pull that item for review to determine if it's actually a good item or a bad item. If you get a negative discrimination, what it's saying is that the least knowledgeable examinees are getting the answer correct for that item, and the most knowledgeable of the examinees are getting that answer incorrect. And this can happen for a variety of reasons. A lot of time it's just a miskey. You accidentally put in the wrong answer. Of course, the students that really know what's going on are getting the answer incorrect because it's incorrect on the key. It could be just a poor item where there's something about that item that is confusing, like absolutes or something like that. It might have a grammatical cue that the higher, most knowledgeable examinees are not picking up and the least knowledgeable are. And then also it could be an indication of cheating. What's the relationship between difficulty and discrimination? Well, if an item is very, very easy or very, very hard, it's not likely to be very discriminating, right? Because if everybody's getting the answer correct, it's not adding a lot of variability. And if everybody is getting the answer incorrect, then you're not getting a lot of variability. So for example, if you have a p-value of 0.97, this means that this item is very, very easy. So your D is going to be pretty low. It's still positive, but it's not really able to distinguish between the high groups and the low groups. It's not very powerful in that discrimination. Let's look at how you can calculate this. Now, I want you to look at this grid, and what we've done is this is a multiple choice item. Okay, there's items A, B, C, and D. These are your choices. B is the keyed response because it has a little asterisk, and A, C, and D are the distractors. If you notice, we've sectioned out the students into 3 groups, the upper, middle, and lower group. In the upper group, there's 100 plus 400 plus 400 plus 100, so there is 1,000 students in the upper group. In the lower group, there is also 1,000 students. There's 300 plus 200 plus 300 plus 200 also gives you 1,000. And in the middle group, we have 300 plus 900 plus 600 plus 200, so that is 2,000 students. Okay, so 1,000 upper, 2,000 middle, 1,000 lower. As an aside, when you divide up your students, if you wanted to do this by hand, you don't have to necessarily have a middle group. If you wanted to, if it made it more simple, you could have an upper group and a lower group only. For the sake of an example, we've decided to keep these values as 1,000, 2,000, 1,000, but this does not have to be the same distribution for your own classroom. Okay, it just kind of depends on how you want to do this. So for the p-value, remember that the formula is the number of students that got the answer correct divided by all the students that answered the question. So here's B with the asterisk, which means that this right here is the correct answer. So of the students that got it correct, there's 400 plus 900 plus another 200. So let's look at how many students got this correct. We have the 400 plus 900 plus 200, and we get a total of 1,500 students. And we know that there's 4,000 students total, right? We've got the 1,000, the 2,000, and the 1,000. So if we divide that by 4,000, we would get that this question, it's not too difficult, not too easy. It's 0.38, moderately difficult maybe, might be a way to describe it. About 38% of students are getting this answer correct. Now let's look at the discrimination. Okay, remember that's the proportion of students in the upper group, and from that you're going to subtract the proportion of students that got the answer correct in the lower group. So here we have 400 of the 1,000, 400 of the 1,000 got the answer correct, so 0.4 as a proportion. And here we have 200 of the 1,000, so that's going to be 0.2 as the proportion, right? And to prove it to you, I'll go ahead and clear this out. 200 divided by 1,000, and we get 0.2. So if we now take the difference between 0.4 and 0.2, the upper group proportion minus the lower group proportion, then we're going to get 0.2 as a discrimination. This is a positive value, so this is looking good. Let's look at the other things here. Let's look to see where students might have made a mistake. Well, if looking at the upper group, there's something about C that is confusing my students. My upper group is really split between choosing B and choosing C. Okay, the same thing kind of happens here in the middle group, where most of the students here got the answer correct, B, but it tricked a lot of these students. So what that might mean is that you have an ambiguous alternative, an ambiguous distractor here. There's something here that might be confusing the students. Now, does this mean that it's a bad question? No. Remember, it only means that you should pull the test and look at this question and make a decision for yourself and for your own classroom to see if that is what you want. Let's do another one. Same exact thing. We still have 1,000 students here in the upper group. We still have 1,000 students here in the lower group, and we still have 2,000 students here in the middle group. This time the correct answer was A. So if we wanted to find the discrimination, remember we add up everybody that got the answer correct, and we divide it by everybody that answered the question. So here, let me bring over my calculator again. Clear, clear, clear. We've got 900 plus 1,600 plus 500, and we get a total of 3,000. We divide that by the 4,000 students that attempted the question, and we get 75, okay? So your difficulty value, P, is 0.75. Means that this question is pretty easy. 75% of your students are getting the answer correct. It's a pretty easy question. Now let's look at this one right here, which is the discrimination. Remember, that's the proportion of students in the upper group that got the answer correct, and you're going to subtract from that the proportion of students in the lower group that got the answer correct. So here we have 900 out of the 1,000 that got the answer correct. That is going to be 0.9. So 0.9 minus the 500 divided by 1,000. We know that's going to be 0.5. Okay, so we've got 0.9 minus 0.5, and we get a 0.4 discrimination. So again, this is a positive discrimination, which is good. It's pretty discriminating. Okay, let's see if there's anything here. Well, it looks like all the choices were selected. You know, my upper group really understood what was happening here. The same with the middle group. By all accounts, this looks like it's a good item. Yeah, so it's moderately easy and positively discriminating. All the distractors were used. There was no ambiguity where one distractor actually confused my upper group. So this looks like it's a good item. Let's try this one. And if you want to pause and figure it out before I figure out the answer for you, that's fine. Go ahead and pause here, and I will meet you when you start back up again. Okay, if you decided not to pause, or if you're coming back, here is how to calculate this. Remember, for difficulty, we're going to take the number of students that got the answer correct divided by the number of people that attempted the test. So we still have 4,000 people that attempted the test, and from that we have 1,000 plus 1,500 plus 500. So if I added that all up, if you want, I just want to do this for people that are wondering where these numbers are coming from. I'm going to get 3,000. So 3,000 of the 4,000 got the answer correct. That means 75%. It's moderately easy question. Okay. Here I have all of my upper group got the answer correct. So that's, 1,000 divided by 1,000, which is just going to be 1.0, right? 1, and half of the lower group got the answer correct. So that's going to be 500 divided by 1,000. It's going to be 0.5, right? So if I take 1 minus 0.5 to get my discrimination, I get positive discrimination of 0.5. So positive discrimination, good. Moderately easy, okay. Now let's look at what's happening here. Did all the options have someone pick them? No. D, nobody picked D. Maybe that's a Mickey Mouse distractor. There's something about D that everybody knows that is incorrect. Again, this does not mean that it's a bad question. What it means is that if nobody's picking D, there's something about D that is just throwaway. So what's happening here is you've increased the probability of a student getting the answer right by guessing, right? If this D would have been an option, then if the students guessed, they would have had a 25% chance of getting the answer correct, where now they have a 33% chance of getting the answer correct because D was just implausible. Whether you want to do that on your test or not, I always suggest if you want to do a giveaway, just don't even put it on there. Give the students less to read. Avoid this extra distractor. So the last one is, here's the options, A, B, C, D. B is the correct response. So for this one, what we're going to do is we're going to calculate what is the difficulty number. So let's see. I have 500 out of the 4,000, and none of these numbers have changed. 4,000. Get the answer correct. So right now I'm looking at difficulty index of about 13%. 13% of my students got the answer correct. It's looking like a very difficult item right now. Now let's look at the discrimination. It's the proportion of the upper group that got the answer correct, and from that we're going to subtract the proportion of the lower group that got the answer correct. So here I have 0 of my upper group that got the answer correct, and we're going to subtract from that 300 out of the 1,000. So 300 divided by 1,000, I'm going to get 0.3, right? I'm going to subtract that from 0. So 0 minus 0.3, I'm going to get negative 0.3. Now I've got a negative discrimination. Something's up. Again, you won't know until you pull the test. What's happening here? Well, it looks like my upper group all answered that they thought the question was D. That's really where my middle group is also sort of looking at D. I would pull the test and look to see if the answer actually is D and if perhaps I miskeyed this. So this might be an indication of a missed key, that when I put in the answers, I made a mistake. The students that were higher achieving were missing it because I had made the mistake, not them. This does not mean that it's automatically the case. It just is something, again, to tell you, go look at the test, see what's there. For rubrics, the calculation becomes a little bit more complex. And so for this, what I'm going to do, for those of you guys who use a 5-point rubric, and this will only work with a 5-point rubric, I will put a Excel spreadsheet that will automatically calculate the numbers for you. One thing I want to share with you before we finish up is that there's lots of free resources for teachers online. One of them that my colleagues really like is Akindi, and it's free, it's online. Basically, you print out a Scantron sheet for your students to use. You just write the questions on like a booklet and then give them the Scantron, and the only thing they write on is the Scantron. So it's very much like a standardized test. And then to grade it, you basically scan them in either through a copier or through a scanner at home and upload them as a PDF, as one giant PDF into the system, and it automatically grades them and provides difficulty and discrimination calculations for each one of your questions. So it's really, really kind of nice. This is what the sample bubble sheet looks like. This one I made a little bit smaller, but it's a 8.5 by 11 sheet, something that you're probably used to. And one of my colleagues allowed me to use his test to look at some of the questions and how this works. And it gives you the information here. So for example, here, the easiest questions are on the assessment. So here, these questions, 100% of the students answered the questions correctly. Maybe they want to look at this to see if these are maybe too easy and he wants to make it more difficult. For this one, the most difficult questions on the assessment were like question 20, question 14, and question 13, where none of the students answered these questions correctly. Now, does it mean that these questions are poor questions? No, it does not mean that. What it means is that it would be a good idea to look at those questions and determine if in fact those questions are valid questions to use. It will also calculate the discrimination score for you. Here it will tell you which questions are the best constructed questions, where it has high discrimination score, they're all positive, and it also tells you what the associated p-value is. These right here, it's also telling you maybe you want to look at these questions. All of these had a negative discrimination and it had a very high p-value. 67% of the students are answering these questions correctly, but those 67 are students that did not do well overall in the exam. So you can see like lowest performing group is much greater than the higher percentage group. Okay, so that's kind of nice. Again, do you have to do this for all your tests? Absolutely not. You'd go crazy. But if you do have access to technology where you can use this and it's easy for you to use, I say go for it. And especially on the days that your test scores or reflection on your practice is particularly important. So that's it for today. Next time I see you, we're going to do another quick lecture on basic statistics, looking at how statistics can help you with your classroom practices. Stay safe.